Hello, welcome to this video on the negative binomial. This time we're looking at the expectation, the expected amount or the mean, and we're looking at the variance. So if x is a negative binomial with parameters r, which is the number of successes we want, so x is how many, the discrete random variable of how many times or how many trials it takes to get R successes. And P is the probability of success on each trial being independent, of course. The expected amount is R over P. And the variance is, here the variance is 1R times 1 minus P over P squared. Let's have a look at putting this into action. So we've got Charlotte again with her cups of tea. Charlotte buys tea from the drinks machine. Remember, it's a little bit of an unreliable drinks machine. You don't always get a decent cup. The probability that the tea is up to Charlotte's standards is 0.75. Each purchase is independent. The random variable x represents the number of purchases required to get 7 teas up to Charlotte's standards. We're going to find the expected amount and the variance. Right, let's have a go at this. So, EX equals R. So, R over P, so we've just got 7 over 0.75. Well, that's like 7 divided by 3/4, I suppose, which is 7 times 4 over 3. So we've got 28 over 3, if you want to leave it like that. So 3's into 28, goes 9 times, with 1 left over. So you'd expect 9 1/3. And although you can have 9 1/3 purchases, an expected amount or a mean doesn't have to be an integer, even if contextually it doesn't quite fully make sense. Hopefully that makes sense. That was R over P. Let's have a look at the variation of x. So that's going to be R times 1 minus P. So R is 7. 1 minus P is 0.25. So I'm going to do this without a calculator, so I want a fraction. 7 times 1 over 4 over P squared. So that's 3 over 4 squared. So, well, I've got 7 over 4. And then we're going to divide by 9 over 16. Well, okay, because that's P squared. 3/4 or 0.75 squared is 9 over 16. So I can say, okay, 7 over 4 times 16 over 9. Simplify that a bit because 4 goes into 16. So that's 4 times 7, 28. So I've got 28 over 9. And that's going to give me 3 and 1/9. So I've got a variance of 3 and 1/9. Well, I've asked you to find the variance here. In fact, to find the standard deviation, remember, what do we do? Yes, that's right. We square root the variance. Excellent. Okay, well, let's move on to a slightly different example. We're looking at Lucy's purchases now. Lucy doesn't like tea. She buys choco milk from the unreliable drinks machine. Each purchase is, of course, independent. The random variable y represents the number of purchases required to get 8 chocolate milks that Lucy likes. So she wants to get 8 good ones, 8 ones she likes, and there's a random variable y on how many purchases it takes. So not every purchase will necessarily give you a good choco milk. This could be any number from 8 upwards. We need at least 8 to get 8 good ones, but it could be any number above that. Given that the expected amount, EY, is 10, we're going to find the probability of Lucy getting a nice choco milk in any one purchase, and we're going to find the variance. So let's have a go at this. We know, well, EY is going to be R over P. Well, let's substitute what we know. We know, I'll just do number 1 down here. We know that the expected amount is 10. We know we're after 8. And we know, probably don't know the probability. So we know expected amount is R over P. So I'll just substitute the numbers in. And we obviously get 8 over 10. Or the probability is, so probability is 0.8, or if you like, 4/5. Well, let's have a look at using that to find the variance. So the variance of y, we just use our formula. This one down here. So the variance is R, which is 8. That's how many good choco milks we need. 1 minus P. Well, 4/5 is the probability, so we want 1/5. Now we're dividing by P squared. Well, I'm just going to do it with fractions. With a calculator, it doesn't matter. You could do either. Depends what it wants as well in the question. So over 16 over 25. Okay. Well, let's have a look at this. We've got 8 over 5 divided by 16 over 25. Oh, that wasn't very good, was it? So 8 over 5 times 25 over 16. This looks like it's going to turn out quite nicely. Mix things around a bit. 8 over 16 is a half times 5. So I'm going to have 5 over 2. 2.5. So I've got a variance of 2.5. What would I do if I needed the standard deviation? That's right. I would, of course, square root. Well, the point of that was just to look at using these formulae for expectation and variance. I suppose the expectation, or the mean, is logical, shall we say, intuitive. The variation, the proof of that needs a little bit more thinking, but looking into the proof of that and where it comes from is a job for another day. Well, hopefully that's clear. Thank you very much.